Okay, so predicting the ions formed by common main group elements. What is main groups, I hear you ask? Well, I don't, but I'm going to just pretend. So main groups is group 1 and 2 and groups 13 through 18. So now you know. So these are the main groups. So everything else you don't need to worry about for now. Okay. So if an element is in group 1, it will always form a +1 cation. Remember, cations are positively charged because they have lost one electron. So it has one more proton in its nucleus and it has electrons around the outside. Group 2 elements will always form a +2 cation. Okay, so we'll learn the reasons why when we do electronic structure, but for now, just know they will all lose 2 electrons to form a +2 cation, which explains why when you organize a periodic table based on reactivity, and reactivity is things like forming compounds and stuff. If group 1 elements are always forming +1 cations, then you'd expect them to react in similar ways, right? Whereas group 2 elements always form +2 cations, so that explains why they react in certain ways. Anywho, we also can add to that just a little bit extra because scandium and yttrium really do behave in quite predictable ways. The rest of this is no man's land, right? The transition metals in general is no man's land, but there's a couple that you can kind of deduce, okay? So scandium and yttrium do actually always form +3, okay? All these other guys, zinc is quite predictable. Again, the reasons for that become a bit clearer later on, but there is only one ion that zinc can really form, which is zinc +2. Cadmium is very similar like that. Silver and gold also tend to just form +1 cations as well. So some of them kind of predictable, right? So what about the anions? So for the anions, I find it easiest to think about this in terms of working backwards from the noble gases, which do not want to do anything, right? So I'm writing a 0 there to remind us that noble gases do not want to form cations or anions. Thank you very much. We are fine as we are. So if you go back one more, so counting backwards from the right-hand side, to the halogens, these all like to gain 1 electron and form a -1 anion, and that is predictable for fluorine, chlorine, bromine, etc. This is what they always do. They do not form anything else, okay? So this is what's called a predictable charge of these anions. The same for the chalcogens, oxygen, sulfur, etc. always form a -2 anion. Nothing more, nothing less. So we're just counting across from the right-hand side. So 0, -1, -2, and then group 15, the pnictogens, always form -3. If we're somewhere in the middle here, like carbon, silicon, it could be +4 or -4. They tend to do more like molecular bonding. They don't really tend to form ions very often, so we don't have to worry about those too much. Boron is also kind of funny, but nominally it can form a +3 ion, but certainly aluminium, gallium can form +3 cations. So you can see the kind of pattern here. So that is quite common with those two. With other metals that you may sometimes come across, indium can form +3. That's generally +3 or +1. Thallium, you're not going to come across that because it's super, super toxic. But tin, remember tin is stannum, so that's tin and lead, plumbum. Those two you may come across, and those ones are similar to the transition metals, no man's land, as in they can form 2 different cations. So there's many different cations that can be formed by the transition metals. Tin and lead can form +2 or +4, which means a little bit later on when we get to naming elements, you do actually have to show the charge on tin and lead the same as you do with the transition metals, but that's enough of that for now. Okay, so we're given scandium, we're given the symbol that tells us it's a +3 cation, so we can just check cation. Sulfur, so go find sulfur in the periodic table. It's over here in the chalcogens. So if it's a non-metal, it's generally going to form an anion, right? So metals are going to form cations. That's the general rule. So if it's on the left-hand side up to that wiggly line, it's going to form cations, and non-metals tend to form anions. Okay, if I could type. So sulfur, non-metal, going to form an anion. Count backwards across from helium if you need to. -1, -2. It's going to form a -2 anion. So to write the symbol for that is going to be sulfur, and then superscript, which I'm just going to show with that little thing, is going to be 2-. Remember, you write the number before the charge when you're writing ion symbols. Okay, so sodium, remember, is Na, so it's there in the alkali metals. So it's always going to form a +1 cation. So I can just check that in there. So that is going to be Na superscript plus. So if it's +1 or -1, you do not include the number. You just have a plus or a minus. That is the rules. Fluorine, where are you? Fluorine over there at the top of the halogens, group 17. So it's a non-metal. It's going to form an anion. Check that one. So that'll be fluorine minus, symbol for fluorine is just F, so superscript minus, okay? So that's what I mean when I'm talking about if it's a +1 or a -1, you don't include the 1. And then lastly, barium over here, down the bottom of group 2. So that's an alkaline earth metal. It's always going to form a cation, and the charge on that cation will be +2. So barium superscript 2 plus will be that cation. Okay, so let's have a little rinse and repeat and see what else we have showing up. So the periodic table is your friend here. Sulfur, sodium, it's basically giving me all the same stuff. Let's do another one. Boring. Is that all we're going to get? Okay, here's some different ones. Yay, okay. So lithium is in group 1. Pull up your periodic table just to... So here's lithium, right? Group 1, so it's going to form a +1 cation. So it'll just be lithium superscript plus. That is a cation. It's lost metals, lost electrons to form a positively charged species. Beryllium is here at the top of group 2, so I'd expect beryllium to also form a cation. Beryllium's a bit funny, but you don't really need to know about that yet, so that'd be Be2+ superscript. Iodine over here in group 17, so that is a -1, right? So that's an anion. So I superscript minus, and then oxygen over here in group 16 is a chalcogen, so -1, -2, it's going to form a 2- anion, so check the anion box, and the symbol will be O superscript 2-. Okay, so just always go back to the periodic table to help you out with this one.